From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
The thing I'm looking forward to the most in 2021 is Laser Wars. And I think that we're going to see like the quality systems that are going to be set up for additives really kick into gear this year. So with Laser Wars, we've got like the SLM NXG 12 laser machine coming out, Velo Sapphire XC. If you know me, you know I'm a diehard Velo girl. Like, I love Velo. And then I think the only other one that I'm really watching that I think is like the comeback kid, or like not so much the comeback kid, but like the one that like the underdog that you want to keep your eye on is the machine from the Additive Industries that they kind of debuted but didn't debut at Formnext, that metal fab one. Right now it's the biggest, and it's claiming to boost the same print rates as the SLM like 12 laser machine, but with fewer lasers. So I'm like, all of these lasers, how are you all qualifying these lasers? I want to know like how they're handling like all that laser overlaps and all of those things. So with the increase in lasers, I think there's going to be a huge push this year to really lock down like what is going to be like the qualification, especially in multi-laser printing.
That was S.J. Jones. S.J. is an additive manufacturing application engineer at Siemens Energy, where she focuses on helping to bring metal additive manufacturing solutions to the problem of climate change. S.J. has a wide array of experience working in the metal 3D printing space, first as a small company supporting the aerospace sector, as well as continuing on there as the company was acquired by Aerojet Rocketdyne. We talked today about her career in the AM industry and her approaches to evaluating technology that is changing at a breakneck pace. She also gives her perspective on the laser wars impacting all facets of the metal space today. She shares some great advice on how to overcome the fear of failure, especially when you're dealing with million-dollar machines and builds that cost thousands of dollars. SJ, welcome to the show. Why don't we just get started with how you got your start in additive manufacturing?
Okay, sure. Cutting right to the chase. I got my start in additive manufacturing back in college. I took a class on rapid prototyping, and the moment that I saw that, like, you know, I had that moment that everybody has where you like make it in CAD and then you see like the physical object and you're like, I like that. Can you do more? Can you teach me how to do more? And so that was kind of like how I really got my start.
Was it common? Like, was there kind of a class or kind of instructor that kind of was leading the charge?
We had a class. The class was called Rapid Prototyping, and I'll never forget that the first thing that I ever made, like I'm an avid skateboarder, so the first thing I ever made was like this 3D printed mount so I could stick my iPhone into the deck of my skateboard and film myself while I was skating. I pushed all my teammates into like, I bullied them all into like letting me do this. And so they were like, okay, fine, we'll go with your project. So we just redesigned my camera mount for my skateboard and my iPhone like 6 different times. And then we printed it across 3 different kinds of printers. Like, of course, we started out with like the MakerBot. And then we went to something on the larger end, like a Stratasys, a smaller, like industrial size Stratasys machine that had the dissolvable supports. But yeah, the whole process, I loved the whole thing from beginning to end. There was always something new to learn or like some way to make the part that I got better. And I loved that. I just couldn't get enough of it.
And kind of what was the team aspect like in that sense? So as you're starting kind of your career in rapid prototyping and additive, kind of what was your first lesson in working with a team around kind of 3D printing, prototyping?
I'm not going to lie to you. My very first lesson was to not get your feelings hurt. And I think it was the hardest lesson because as engineers, we put so much work and thought and time into every design that we make. And we convince ourselves that we have this certain level of certainty that it's going to work. And especially with metals, a lot of the times you'll get it in the machine and then your design doesn't work and you're just heartbroken and crushed and you can't figure out like why it worked the last time, but it's not working this time. And it had a really high learning curve. So like giving myself the opportunity and the space to fail and to be okay with my failures and to accept them for what they were and learn from them and learn that they were teachable moments was probably like the first lesson and the very hardest lesson, and the lesson I am still currently learning.
Yeah, I can super resonate with that. When I started my company kind of straight out of finishing school, and I didn't know anything about business or sales or anything like that. And when you kind of get your pitching, you're kind of selling projects and or whatever selling is at that point, it was very hard for me to not take that personally when something didn't work out or someone went with a different company or firm. And I think you spend so much time cultivating your career, your expertise, and then when someone says no, it was hard for me to not take that personally and have that as they're not like a reflection on you. So I think that's something that I'm still trying to learn every day. And so you're with Siemens now. So Siemens is a huge company, global. Kind of what part of Siemens do you work with?
So technically, I'm a part of Siemens Energy. We had this like super fancy carve out recently.
Okay.
So
does that mean it's a different company?
I used to work in aerospace, and now, yeah. So technically, it's a different company, but yeah. Now I work in aerospace. Not aerospace. I used to work in aerospace. Yeah. So coming from aerospace to energy, it's very similar in that a lot of the parts when I came over, I was like, oh, that looks very similar to something I've made, but then they call it something completely different, and I was kind of just like, okay, so this is like oranges and tangerines. Like you both look the same. You're just slightly different sizes and a slightly different flavor. But yeah, it's exciting working for Siemens Energy because they're working really hard to change the world by making more efficient energy systems and like bringing down like our global emissions and decarbonizing and whatnot. So you really do feel like, the work we're doing is going to have like not just like a personal impact on like a town or a city or a race. Like the work we're doing is impacting the world. So they definitely like resonate with that amongst all their teams. And I think that's like really touching. And it's one of my favorite parts about working for Siemens Energy.
And how do you and maybe the company as well think about how additive fits into that equation of kind of global warming and reducing emissions? Is it the ability to make new parts, or do you think additive in itself is a cleaner / more efficient way to manufacture things?
That's a very heavily loaded question. So first, I think that one of the really awesome things about additive is distribution and supply chains and how it's completely disrupting that. So we don't have to keep as many parts in inventory or in stock, which also reduces costs and also reduces material waste. And then number two, I think that there's a huge potential for additive where if we get a process and a machine down and we lock it down and we can secure that quality, we can eliminate so many steps in the supply chain using additive manufacturing. Like you can take out a lot of tooling steps and whatnot. So you no longer have to ship your part from A to B to C to D all the way to Z. You can just go A, B, C, and then your part is ready for you. So I think it's going to be really interesting in the future if we have like a bunch of like small production plants scattered throughout an area. So if someone is like, oh man, we need this new turbine vane, we can just like find the nearest supply chain like you would on Google, and then you just submit an order, they print it, do all the post-processing, and then get it out to you within like 8 to 10 weeks. And I think that's like one of the things I'm most looking forward to in the next 10 to 20 years. We'll see how it goes.
20 years, according to what I read every day, it's happening right now, right?
It's the hype cycle, man. You gotta double the hype cycle. So if they think it's 5 to 10, then I automatically just double it. So probably like realistically 10 to 20.
Yeah, I caught myself the other day thinking about kind of like how long has additive manufacturing been around? It's not been around that long. And they're like, wait, it's like developed in the 80s. It's 40 years now. So, and kind of along those lines, kind of what do you see as some of the challenges there? One of the things that you mentioned, I have a particular passion for is kind of the qualification, and you mentioned kind of locking down design / machines. Like what's the process like for?
The process is really long. I'm not going to sit here and pretend like I know everything about our qualification process. I'm not a quality engineer. I'm definitely a design engineer, but I can say that the thing I'm looking forward to the most in 2021 is laser wars. And I think that we're going to see like the quality systems that are going to be set up for additive really kick into gear this year. So with laser wars, we've got like the SLM NXG 12 laser machine coming out, Velo Sapphire XC. If you know me, you know I'm a diehard Velo girl. Like I love Velo. And then I think the only other one that I'm really watching that I think is like the comeback kid, or like not so much the comeback kid, but like the one that like the underdog that you want to keep your eye on is the machine from the Additive Industries that they kind of debuted but didn't debut at Formnext, that metal fab one. Right now it's the biggest, and it's claiming to boost the same print rates as the SLM like 12 laser machine, but with fewer lasers. So I'm like, all of these lasers, how are you all qualifying these lasers? I want to know like how they're handling like all that laser overlaps and all of those things. So with the increase in lasers, I think there's going to be a huge push this year to really lock down like what is going to be like the qualification, especially in multi-laser printing.
Yeah, more lasers and more questions / more risks.
More lasers, more problems.
Yeah. And that's been really interesting. I mean, that was kind of the big takeaway from Formnext. It's like the SLM massive machine. We talked to a few folks that are kind of prototyping that system now and have gotten some feedback. And I think from a design engineer perspective, you have to be on top of the technology, especially whatever technology you may be using or the future technology. Mm-hmm. How do you do it? How do you kind of keep an eye on what's happening and to inform your decisions on how you're kind of taking designs or parts to that next level or additive kind of approach?
So right now, that's a heavily loaded question. So let me think for a second. So designing for multi-laser printing, I think, is going to take a lot of work between us and the people who are making the machines. Like we really need to like collaborate more, and we have to come together more as an industry. I think that in additive right now, there's still like that I'm going to go in my corner and develop it, and you're going to go in your corner and develop it. And instead of growing twice as fast, additive is going to take twice as long because we don't want to talk to each other because of like all of this intellectual property stuff. But I think that even like if we just talk more with our manufacturers and we talked more with each other, I think that we could get so much more out of additive. We can only make each other better. So to move forward with multi-laser printing, I would definitely want to have like those conversations with FLM or with Velo or with Additive Industries to talk about like, you know, how they made the machines, test for their machines, check out the software, because it's not just the machine. Like you also have to make sure like the software for the machine is also really good too. Help troubleshoot with them. From their point of view, I would really, really love it if the customer service was like more spot on in 2021 for a lot of these machine manufacturers. I don't want to be playing phone tag for forever. Yeah, sorry. I'm a diehard Velo fan because no matter what time of day or night, whenever I was having trouble with my Velo machine, they would instantly pick up the phone and be like, "Hello, what do you need?" And I was like, yeah, so this happened. And they'd be like, "Okay, well, just push this button." And I'm like, "All right, well, that's fantastic. I can get through so many more of my builds so much faster." But yeah, sorry.
It's like, I mean, going into the customer service part, we haven't talked too much about that. I mean, that's kind of a behind the scenes, somewhat unknown for a lot of people, especially getting into the space. I mean, every time you buy a machine, like a big $10,000-$15,000 price tag per year on that is your service contract, and depending on how readily they're willing to answer the phone, you pay more. But kind of what I mean, I've had a wide range of experiences, and I think that's for different machines, you have different expectations and maintenance. Like for someone kind of maybe thinking about investing in some of their machines or new to the space, like what's your experience in thinking about that from like when things go wrong?
So when things go wrong, so the multi-laser printing thing is a really great like example of that. So if one of those lasers on the 12 laser machine or the 10 laser machine goes down, does that mean that the whole system goes down? That's one of the risks that a lot of OEMs that I've seen are considering. So is it better to buy one M404 or is it better to buy four M290s?
Mm-hmm.
That way, if like your 404 is in need of service or it's like it's due for maintenance and it's down for 2 or 3 weeks, you don't have to worry about that risk so much if you have like four of the M290s. So it's just playing that game. And I think one of the things that we also don't talk about when I see a lot of people set out to make their own additive company, and the best advice that I've been given from people who have done that is to always make sure you know what your demand is. Like, don't do it unless you already have like a secured demand. And so like once you have like a secured demand, then you'll know like the volume size that you might be looking for, that you might want to specialize in, at least for like the first 2 or 3 years. So like if you know you're going to print giant super rocket engines, then you're only going to invest in like super big build volumes. So you obviously have to go with the bigger multi-laser machines. But if you're only printing smaller parts, then it makes a lot more sense to just get the M290s. And I also think that they're cheaper and they're easier to service personally. But
right. And then how do you, I mean, this is one of the things I think about constantly with, especially like we talk to a lot of like small, medium-sized companies who have maybe making that transition to supporting some of the bigger Siemens or Boeing or whoever it may be in terms of helping them grow their additive supply chain. And that's a tough equation for a lot of those companies. I mean, betting for a 30 to 50 person company buying even an M290 that's going to cost you $750K. I mean, that's not trivial. Plus all the building changes you might need, a wet sep and post processing if you don't have it, and powder. I mean, you're inching closer to $1 million.
The gas, don't forget the gas.
For sure. And then you have to train somebody like who may not know, like you're trying to kind of bring your workforce up. And what's I see, I mean, there's certainly a lot of companies doing it well at the big companies, but like the adoption at smaller, medium-sized manufacturers is still kind of inching along as well. Is that something, do you see that as well? Or what are you seeing from where you sit?
I personally see, having worked on both ends, because I started in metals at a startup and then now I'm at, I went through like a bigger company after the startup was purchased, and now I'm at like an even bigger company. I found that working for those smaller like OEMs, like we were only 10 people, and I got more experience working with like the smaller company than I did with the bigger companies. I find that with the smaller companies, they're definitely more able to take risks. They also don't have like all of the regulatory like requirements and the stringent like requirements that we have at the big companies. So now I have to fill out like mountains of paperwork before I can start the print button. And there's mountains of paperwork once it comes out. And all of these system checks and balances to ensure like the super quality of this part. And before it was kind of just like, do you think it's going to print? I don't know. Do you want to just throw it in there and see if it can print? I mean, sure, let's just throw it in there and see what happens. So there's a lot less risk taking at these bigger companies. So I think that that's going to give those smaller companies the edge, is because they're going to be able to explore avenues a lot faster, whereas I'll have to like push through a lot of paperwork before I can get approved to just try sample printing like one little piece.
And do you think with that approach that the big companies will continue to buy some of these smaller companies, or will there be kind of a network of independent suppliers? I mean, we have that to some extent in the prototyping, proto labs, Xometries of the world that's pretty well established, but it's not probably as established. There's some in the production range.
I think that's a hard question to really get my head around with the current like pandemic response. Because I saw a lot of, the OEMs like closing down, the ones that were already kind of like hovering on that delicate line. I think that a lot of the big companies, like the big aerospace companies, are putting their feelers out there. And, obviously they want to encourage competition because, they do recognize that like there's health and having these smaller businesses pop up so that they can pick from the cream of the crop. So I do think that like some of them will be purchased, and I think that some of them will be big and like just stay in their own lane, especially if they, you know, patent something or patent a particular support structure, or they improve a certain thing about a machine and they make it better. We already saw that with, you know, a certain very large manufacturer that developed launchers, super cool, awesome rocket engines that I'm a super huge fan of. So they just extended, you know, the build volume, and then they made this super awesome rocket. And so like that's their thing now. And so, you know, they may get offers to be purchased, but I think that they're going to stay pretty independent for a while.
And kind of you've had in your career the opportunity to kind of work very close, like hands-on with machines. And can you talk about kind of how that has impacted or accelerated your career in learning and your ability to kind of push forward or push kind of the envelope in terms of the technology and what you're doing from a design perspective?
Yeah, sure. So working with the machines was very enlightening. Because I was at a startup, you know, we didn't really have a lot of staff, so we all wore a lot of different hats. And so I would design my build, put it in the machine, start the build, print the build, and then I would have to go out there in like all of the PPE, fire retardant gear, and like, you know, the big mask with the oxygen, and I just have to stand there for hours while my arm was falling off, sieving all of that powder after my build was done. But it did give me a stronger appreciation for design and how things are laid out on my build plates, because, you know, I think I once made a mistake of like printing a part that grew as it increased in Z height over the bolt holes at the corners of the plate. And so it was incredibly difficult to get that part out. And, you know, I learned my lesson. I know I will never, ever do that to myself again. So you have a lot more consideration for the people who are doing it. And then when you do get those express calls where somebody like calls you in the middle of the night, it's an emergency, some machine's broken down and they need like 80 replacement parts, you'll know like the fastest way to set up the build to get it out of the machine so that, you know, the process is way faster. So that's definitely given me a little bit more of a design edge. And, you know, understanding how the machines work and how the recoders work also helps when I'm like designing supports and like orienting parts on the plate, because you want to make sure nothing's going to crash and burn, literally.
I think every person that I've talked to that's run machines has that story of when that oh crap moment of like once they get to the end, like, oh, what have I done? I remember one of my first builds. This was on the polymer side when I was doing a little work, and I had been using nylon for a while and then switched to an elastomer that had lower melting point, and I forgot to change the settings in the actual build kind of chamber. Like there's multiple heaters and I'd forgot to change one, and the whole build got was melted, and so you had to kind of chisel it out afterwards. So you only do that once. But it's luckily I was at a place where it happened. It's a mistake. You learn not to do it again. So
yeah,
okay.
I honestly am surprised that my greatest, like the thing that I've always consistently just messed up on in like metal printing is running out of powder. Mm-hmm. Like it's the one thing that I'm always forgetting, like that I used to always forget to check, where I would just be like, I would start the build and then I'd come back on Monday and they'd be like, did you turn the dosing down? And I'd be like, well, it looks like I did not, because this build did not finish. And I think it's just like learning those mistakes over and over again and like having the space to make them that really has given me the edge in my career currently.
Yeah. And speaking of that, kind of as you reflect, I mean, you're kind of still in the middle of your career and doing a lot of innovative stuff. Like kind of if you put yourself in someone's shoes that's exploring the 3D printing industry for the first time in high school, kind of thinking about college or other trajectories, like what piece of advice do you give them, or are there kind of key stories that you wish you would have done differently along your career?
Oh man. With 3D printing, I would say that's a really hard one. There's so many like things that I'm trying to like cycle through to figure it out. Obviously, take everything with a grain of salt. Don't take yourself too seriously. That would definitely be the first thing that I would tell someone setting out. And then the second thing I would tell someone is to know, like, when you get into 3D printing, you're so excited by just the potential of it. Like, it's almost overwhelming, like the amount of potential that 3D printing has, especially when you're first starting out and you can see all of those possibilities. But for someone starting out, I would tell them, instead of, focusing on like what companies you want to work for, focus on what kind of parts you want to print and what kind of impact those parts are going to have. I think that would probably be my best advice for someone starting out. Like, think about the parts that you want to make, whether it's implants, if you want to make engines, if you want to make veins. Just think about that before you go into 3D printing and focus on that. Because when I started 3D printing, I was just ready to take whatever job like I could get because I was just so in love with it and I was so excited. And I wish I had focused more on like navigating the waters when I was younger to align my path to be more in line with parts that I was like aiming to print, parts that would have like a better impact or a bigger impact on the world. So right now where I'm at in Siemens Energy, I know that I see more now the impact that the parts I'm printing are going to have like on the world. So like that's way more satisfying to me now, and I've never been so satisfied in my career as I am right now. So yeah, I think that would be the main piece of advice I would tell a lot of young people, especially this Gen Z.
That's awesome to hear. And I mean, I guess there's kind of just following up on that, like one of the things that I think about it as well is you've had this great experience of working for both a small company where you're kind of hands-on, like you have to do whatever is necessary. And then with Siemens, I imagine there's a little bit more bureaucracy, like things like there's defined roles, like job descriptions, like that are actually written out.
Yep.
When people are like kind of navigating early on in their career, I guess maybe just talk specifically to Siemens, like what do you advertise specifically for 3D printing or additive manufacturing roles, or do you kind of get like, maybe you get funneled that way if particular interest? What do people like actually look for when they maybe want to look at a Siemens or another big company?
So other, like what I consider big companies, I think Xometry to me is a big company because they started out small and now they've grown like really, really rapidly, and they have a wide network, and it's really easy to check and see like, they're hiring for like FDM, or they're hiring for a machinist or something like that. But with Siemens and the larger companies, they tend to be hiring more so for expertise. There are some internships that do pop up, but they do tend to hire more for expertise. And for someone who's looking to move over to like those larger companies, I would tell you to adapt your skill set. So it's not just enough to know how the machines work and to understand 3D printing. Now we're definitely moving towards this era of like, there's a lot of simulation involved. And at the previous like smaller shops that I've worked for, it was just the customer comes to you, they give you the part, they tell you, I want it printed this way, this way, this way, and this way. And I want this post-processing, and then I want you to deliver it to me in 8 weeks. And then you're like, confirm or deny. And so they're like, okay, cool. And that was it. That was my whole job. The part would come in, I would set it up, I would print it, send it off, and then deliver it to the customer. Whereas working for Siemens Energy now, it's very comprehensive. So like, I no longer just get the part. I get the part, and then I have to work with the engineers to understand like all of the pressure constraints and the fluid constraints and like the life cycles for the part, the heat stresses it's going to be under. Is it going to survive with this material, or should we take that material? And I'm so involved in the whole process. I'm just blown away. I'm in the room just kind of hoping that no one asks me a question most of the time, unless it's specifically about the printer. But like, then I know exactly like the impact this part is going to have and like how it's going to change the performance. And I'm in the room when they're making these big decisions on whether or not, like, should we go with additive or should we stay with conventional? So they really do their homework before they make any avenues. into the additive world. And I appreciate that as someone who has to print things. So yeah, that would be my recommendation. Learn your simulation software, understand how it works, understand the background of the parts that you want to print. So if you want to print engines, understand how engine parts work. If you want to print like biomedical stuff, understand, how surgeons work, understand ergonomics and things like that. And if you bring those extra skill sets to the table, then there's a much better chance of you getting hired, or at least networking your way in through the door.
So understanding that full context of like, why is this being 3D printed? Mm-hmm. What's like connecting the full story mm-hmm. is like, we could save by doing it this way, we can save time to install or assembly costs. But then also, as we think about how it integrates into the build and the materials that we could use half recycled or something like that, we can start to really have that full story together. And I totally agree. I mean, I think that's something that hopefully as the industry matures, as you start to get those end-to-end stories that like actually make sense for the capabilities of the machine, right? I mean, there's a lot of parts that don't make sense. And especially if you start to consider having 8 people in a room for 6 months and the cost of doing that to redesign the single part that you're going to make 10 times, that better be a pretty big business case. and so I think that's 100% right on that front, and something that it just goes to with the whole theme of manufacturing. Like how does something get to the point where it's shaped like an iPhone or like an engine block? Like there's a lot of why that you have to kind of circle all the way back to the raw material probably to get those answers. So as we kind of wrap up here, the 2021 just started. Kind of what's exciting you about kind of the year to come and in additive and in your career as you make progress forward?
So I already told you I was excited about laser wars because that's basically what I'm up all night on the internet searching. The other thing that I'm pretty excited about is entomology. I'm like a big entomology geek. They're just rapidly prototyping, not really prototyping, but they're releasing all of these new like stages and suites and notebooks every couple of weeks. So like just when I think that they've raised the bar, they're like, oh, by the way, we're doing this now. And I'm like, if you keep raising the bar, I'm going to be out of a job. But their software is really amazing and it's come a long way. So I'm really excited to hopefully get my chance to incorporate a lot more of their tools into some of my designs this year. Maybe we'll see. It typically takes a little bit longer than that in a realistic world, but I'm pushy. So I've got my fingers crossed.
Fantastic. Well, I appreciate you sitting down with me tonight. Thank you so much for your time. And I look forward to hopefully meeting you in person sooner rather than later.
Same. I'm hoping that you stay safe and I wish you well.
All right. Great. Thank you so much.